So welcome to U-Systems podcast, Collaborate to Innovate. This is Imran from Brookhaven. Would you like to just introduce yourself quickly?
Well, thanks for having me, Kate. It's an honor to be here. It's an amazing event, Supercomputing 24. I am with one of the 15 national laboratories with Department of Energy, Brookhaven Lab here in New York. So I'm responsible for the operations of the data center. We do lots of compute in our data center. And I'm also involved with many collaborations worldwide where we talk about how to improve the carbon footprint of the data center industry.
Yeah, of course. So what do you think sustainability is so critical for our industry today?
Well, that's a great question. I think it's really important to talk about sustainability because this unprecedented growth of AI, has taken everybody by surprise.
Yeah.
It's just not going to stop anytime soon, and we know we are hit by a power crisis. And these GPUs and CPUs are really consuming a lot of power. So it's really important to make these systems more efficient so we can conserve power. And not just conserve power just with respect to saving the power, but also we need to talk about saving expenses for the operations and the upfront capital. So all of that is tied into sustainability, and obviously, the more we produce, more emissions are going to be, in the atmosphere and the planet. We need to think about our planet as well.
Yeah.
So sustainability is the key problem right now in this industry as it grows exponentially.
And what role does liquid cooling play within that?
I think liquid cooling is really instrumental, and it is essential, I think, at this point. And the reason why I'm saying this is essential is because the growing thermal design power of the chips will inevitably require liquid cooling. So this is one reason why liquid cooling is really important. But at the same time, if you look at the opportunities that come with liquid cooling, for example, if we were to do liquid cooling of a chip, we can really think about higher temperatures that, we get in return after the water has taken that heat away from the chip, which could be used in many meaningful ways, such as heat reuse. And also, from the basic thermodynamic properties of the water, water has 3,500 times more heat absorption capabilities than air, and also it moves 7 times heat faster than air as well. And there's limitations to how much you can cool with air. So for that matter, I think liquid cooling is really important.
Is the future.
Yep.
And there must be some challenges with adopting that, though. Could you elaborate on some of those?
Absolutely. Liquid cooling is certainly essential, as I said, but it comes up with a lot of challenges, such as the heavy upfront cost, the adaptability. We have liquid cooling, which is now being implemented in legacy facilities, which may not be ready for liquid cooling adaptation. So the adaptability in legacy buildings of liquid cooling is also a challenge. Also, the operability of these systems, the maintenance. So we need people who are the data center staff who is really savvy with dealing with this kind of infrastructure, how to operate, how to maintain the state-of-the-art complex system is also important, because when we talk liquid cooling, it's just not a chip attached to a cold plate attached to a chip. We're talking about immersion cooling as well.
Yeah. And
we're talking about a single phase and 2 phase. So I think it's really important that the skill set is developed soon, and there is some sort of standardization that happens in the industry. So a fast adaptation can happen, but for now, I think there are challenges that I have mentioned, which are surfacing right now.
So you mentioned obviously the very quite high costs, whether that's OpEx or CapEx. But is there any way that we could maybe repurpose the heat from liquid cooling to make it a bit more
Absolutely.
financially good?
Yeah, absolutely. As I said before, heat reuse is really important. It's just basic law of thermodynamics, right? So you can create energy, but you can transform energy from one form to the other, right? And this is where the heat that we are rejecting from the data center at a cost, right? We should be taking that heat and using it for some meaningful purpose. We just saw the Olympics in Paris, and the swimming pools used in the Olympics, the water was heated from a data center nearby. Europe is really facing high energy crisis, as we all know,
Yeah.
post pandemic and post, wars, I guess, still ongoing, which has really soared the energy, the oil prices, and it's really important to understand how we can effectively use the heat that we acquire from the data centers. There are now uses such as district heating. There is a huge piping heating network that is housed under the roadways in urban areas, and the data center heat can really be looped into that district, and it can then heat multiple homes and be used for other industrial purposes. There's been fish farming, there's been agriculture use of that. So there is so many ways this data center heat can be reused. And as we know, in Germany, leading the way, within the heat reuse applications, they have this Energy Act where data centers are now mandated to use the heat from the data center in some shape or form. So I think rest of the world should also be, following that trend,
Yeah.
so that we can really save on emissions and really save on energy. And this data center industry is only going to be expanding. So is the heat opportunities.
And definitely when it comes to the emerging technologies of other liquid solutions, they must be taking into account the repurpose of the heat. So would you say that immersion would still be the number one, or will become the number one go-to?
That's a great question. And as I am researching with many collaborations worldwide, speaking to a lot of people within these conferences and events, and seeing the trends in the industry, it looks like immersion is definitely some a cooling technology which is going to be adapted ultimately, I believe. I think the adaptation overall of liquid cooling is slow.
Yeah.
I think overall there are probably 60 to 70% of the data center which have not yet adapted liquid cooling worldwide. So I see the adaptation of either liquid cooling technology is going to be slow, but immersion might just be a bit more slower because of the way the whole immersion setup is. But I think with the technological advancement and with the mineral dielectric oil getting more advanced, and some of the environmental concerns about the oil getting resolved, I think the adoption of immersion cooling, let it be single or two-phase, might be coming faster than we thought.
Okay. Do you think there'd be any kind of stepping stones in terms of using one or two technologies together? So whether that's immersion and rear door, or direct and rear door, or something like that?
Yeah, I think this is again a great question, because it really depends on the type of use and the business need for that matter. I'm seeing a lot of enterprise computing using, or maybe a small scale HPC for that matter, might be using a hybrid approach.
Yeah.
They may not have the densities reaching up to, in the vicinity of 60 or 80 kilowatts per rack. So they might still be using either a rear door heat exchanger or a combination of rear door and direct to chip.
Yeah.
So I think it's really going to be dependent upon the use case, but I do see lots of hybrid cooling schemes coming into play to achieve those, efficiencies for that matter, and reduce the operational cost.
And when it comes to the changing landscape and architecture of data centers, is there a real focus on using renewable energy? And if so, what would you recommend the most using?
Sure, I think renewable energy is a very hot topic, and what I really like is that the collaboration among the competitors such as Amazon, Google, and Microsoft, they have really joined forces in regards to addressing this global, challenge of energy crisis. Renewable energy is going to be required anyways, just because of the power crisis we're seeing. And we are seeing not just, and obviously hydro is probably one of the best ways when we talk about renewable energy, but at the same time, I think the adoption of the small modular reactors, such as nuclear, is really coming into play, just because we may not be able to have the existing grid able to carry all that transmission, the additional power to the data center, right? Fast enough, because the way the evolution and the adaptation is happening, data centers are really growing very fast, right? So it may not be possible for the data center owners or the investors to be able to bring power faster to the data center. In that case, they may have to look for alternatives such as maybe solar, or for that matter, small modular reactors, like I said, or nuclear, on-site nuclear power generation. So it is really important to think in all facets of renewable, not just like, just maybe wind or solar or hydro. I think it's going to be really interesting few years coming up, for that matter.
I think that's the best thing about our industry. It's really progressing society using, like you said, technology that isn't solar or wind, and just trying new things.
Yeah, exactly. I mean, really have to be open to all the options, whatever suits you. And obviously, we need to look at the jurisdiction, the legislation we are in, right?
Of course,
obviously, there are some countries who might be, favoring one versus the other type of renewable source of energy. Like certain countries, they are giving a lot more incentives to the industry, including data centers, with respect to having more rebates, more subsidies for that matter. So that is a great driver for the data center owners to be thinking about solar only, for example, right? Whereas, in certain countries, it may not be an opportunity. So I think it's going to be a blend of exactly what suits you, for the most part. But I do see renewable becoming a certain, inevitable, requirement coming up in the coming years for sure.
I mean, definitely with the speed of advancement with our industry, there must be a lot of gaps in terms of metric standards and policies. What would you say would be our biggest, most concern at the moment?
About the policies you said? So I think it's really an important topic that you have touched upon. I see a lot of interaction from the government side, right, with the industry in many continents, especially here in the US. There is a lot of talk about decarbonization, and also there is a lot of funding being available, right? Lots of funding available from various government institutions, where the startups and academia are joining forces to come up with more innovative, more energy efficient solutions for that matter, which in turn, will obviously solve the energy crisis, and also the scope 1, 2, and 3 emissions for that matter. So it's really important that the policies are in place which are going to favor the industry, including data center industry, which as we know, might be consuming 4% of the global power by 2030. So it is really important that the policies are, set in a way that it really favors these types of industries.
And kind of what other trends do you see that will continue to shape our industry in a more sustainable way?
I think with this evolution of AI, HPC, big data, it's really important that we talk about edge computing, to obviously reduce the latency for that matter, because speed matters, as we know. Itself, within AI and HPC, the advancement of the chip itself, the standardization is very important. There's a lot of fragmentation that I see in this industry, which may not be, super helpful to standardize a typical kind of, let's say, liquid cooling solution. So I believe that, we are in a situation where we need to rise together, and we can only do that by, shaking hands and joining forces for that matter. I see heat reuse, as we said, it's a big thing coming up, I think globally. That's something we need to talk about. And also, what has been really lacking in terms of a key metric when we talk about energy footprint measurement. Like we know PUE is one of the major metric when we talk about measuring efficiencies for that matter. But this is measuring the power and efficiencies at a very high level. We need to now dive deep into the chip level, right? So when you talk about the efficiency, flops per watt, for example, we need to talk about the availability for that matter. We need to, break down into the node itself and see exactly where we can improve on the electronics themselves, not just the silicon, right?
Yeah.
To better understand the power envelope. So we need to probably come up with more energy metrics, right? Which I see there's a lot of work going on, such as OCP is really leading the way in that sense. I know ASHRAE is also trying to do a few things. So this is really what I see coming up as trends in the next few years.
I really like that, and like as you said, it's all about the collaboration and open communication. That the three that you mentioned, Amazon, Microsoft, and that are kind of telling us the way to go. It is through working together to create a better place.
Absolutely. We need to understand the difference between competition and collaboration. Competition will always be there, obviously, but we are in a very niche market where collaboration is really needed. In certain aspects of the globalization of this data center, growth. So, and I do believe that what I'm seeing, I was at OCP not too long ago, and what really fascinated me to see, the big tech companies are now really working together, like I said, on a renewable, energy crisis. They're coming up with some common thoughts. There are now new chip standards such as RISC-V, which I see was recently adapted by, all the big tech companies. So this is really important and a great sign for the data center industry to be really understanding the need of the hour and kind of like join forces and collaborate.
Well, what a great way to end our questions. I do have a set of quick fire ones. If you're ready. Okay. What would be your favorite word or phrase?
We don't have enough power.
Fair enough. And what are you most looking forward to?
I'm sorry?
What are you most looking forward to?
So I think I'm really looking forward to more collaboration and more sense of urgency globally among the data center stakeholders to be really, like I said, diving deep into understanding the energy envelope of the electronics, the node itself, so we can better understand really where the inefficiencies lies and how we can make it more efficient.
Okay. And what lesson do you wish that you had learned sooner?
Well, I think the lesson learned is really irrelevant at this point, because the way technology is evolving, what you learned yesterday may not be valid tomorrow. This is a very fast-paced industry, but I would say that really having the need of a trained workforce, who is really motivated to play a role within any organization would be a key. Having a staff of like-minded people who are really willing to take upon the challenge and be able to adapt to new skills is really important, because without workforce, a trained workforce, I don't think we can really solve this puzzle.
Yeah, 100%. And finally, what does AI mean to you?
Well, I think AI is really wonderful, I have personally been using ChatGPT a lot, I'm not gonna lie. As of lately, imagine if you were called into a meeting out of the blue, right? And you may not be ready for the meeting, there goes ChatGPT, right?
Yeah.
I think AI is really wonderful, and there is no stopping to that. I think the ethical challenges that comes with AI is something that we all have to ponder over together to see if we can really solve the unethical use of AI maybe. That is something I see as a challenge. But other than that, I think AI is all for good.
Oh, I love that. Well, thank you so much for joining us today, and I look forward to hearing from you again.
It was a pleasure. I hope you enjoy the rest of the SC.
Thank you very much.
Thank you.